What is going on, guys? Mr. C here with lesson 10.6. We're going to be talking about circles and arcs today. So moving away from area, at least for today, we'll go over area of circles next lesson. But just going to be dealing with circumference and arcs, which are basically just portions of the circle. So there's going to be a lot of information thrown your way during this lesson. Some of it will be review, some of it will be new. But there's a lot of different parts to the circle. So bear with me and do your best to keep up. So let's go over the different parts of a circle. Obviously, a circle is round. You guys all know that. You guys know what a circle is. But it has a center. Okay, circles all have centers. Okay, which is a point. Basically, it's saying that the distance from that center to anywhere on the circle, these are all the same distances. We know those as radius, or the radii. So every circle has a radius. Well, I color coordinate these things. Every circle has a radius. Twice the radius, or that full distance from one end to the other that goes through the center. It's called the diameter. Okay. And notice when we make these different lines that go through the circle, we actually create some angles in here. So like this thing here. Okay, we refer to this as a central angle. Okay. It's called a central angle because its vertex is the center of the circle. So we call that a central angle. And there are different portions to the, what did I say, different parts of the circle? I don't know what I was trying to say. Different parts of the circle that we can name called arcs. Okay. So if this is like A, B, and C, okay, there's different arcs. For example, like this here is an arc. Okay, it's basically just a part of the circle. Okay, we would refer to this as arc BC in this case. Okay, and we do a little arch or arc symbol over that to signify this isn't a segment we're talking about. This is an arc. Okay, so that's arc BC. We would refer to that as a minor arc because the central angle here that creates this arc is less than 180 degrees. If we wanted to do like, say, this arc here, follow that all the way around. Now, this is where we need to differentiate a couple things when we're naming these arcs. Notice this arc goes from B all the way to C. However, we already have an arc named, what did I say, B all the way to C? Sorry, it goes from B all the way to C this way. I went in the opposite direction. Doesn't matter. But this is the arc, goes from B to C. Now, we can't call this arc BC because we already have an arc BC. So if we're naming what's called a major arc, an arc that's greater than 180 degrees, so an arc that's basically greater than half of the circle, which this arc from B all the way to C here is, we don't refer to this as arc BC. We find a point between it, and we would name it this way. We'd say that this is arc BAC. Okay, because this goes from B to A to C. Just a way to differentiate between these two arcs, because BC is that shorter distance, BAC is the longer distance from B to C. Okay, hope that makes sense. But yes, that is the difference between BC and BAC. Okay, naming those. We can add arcs just like we can add angles. So let's talk about arc measure. So every arc has an arc measure. Keep drawing ovals. There we go. An arc measure is not too bad. Let me draw a center. Let's draw an arc here. We'll call this arc AB. Now let's see, we have I don't know, let's say this is 80 degrees here. Okay, an 80-degree angle. Now the measure of this arc here from A to B is the same measure of the central angle that connects this arc. So what I mean, this angle here, okay, this 80-degree angle, its two endpoints right here are A and B. So this arc, AB, has the same measure of its central angle. So this, we write it as the measure of arc AB. That's 80 degrees. Okay, so if you see the central angle, this arc measure here is the same as that central angle. Okay, so that arc has a measure of 80 degrees. Right? Now if I had another point out here, let's call this C, and I wanted to find the measure of arc ACB. Okay, the measure of arc ACB, even though it doesn't give me a central angle here, I should still be able to find out what does this arc measure. Think about it this way, all the way around the circle is 360 degrees, okay? So if we take the 360 and we subtract this portion, just the 80 degrees, that's going to give us what's left. So it's 360 minus 80 should give us a 280 degrees for the measure of arc ACB. This is 280 plus this 80 is all the way 360. Okay, so you get that by subtracting the two. That's how you get the 280. All right. Okay, and last thing we're going to do for today's lesson is adding different arcs. So if we wanted to add two arcs, say I had this here, and this was, oops, that there, and we had, let's say 120 degrees. We'll give ourselves another point D here. We can add two arcs just like we can add two angles. Like if I wanted to measure or add the measure of AB plus the measure of BD, right? That's just going to be their arc measures added. So 80 plus 120, that's going to give us AB plus BD. That is 200 degrees. Okay, so that's what you guys are going to be working on right now. All right, so go ahead, get started on today's homework. If you'd like, we're going to go ahead and continue on in the lesson, and we're going to be talking about circumference and arc length. We're going to start out by talking about circumference. Circumference, a good way of thinking about that is basically just, it's perimeter, but for a circle. Okay, just like perimeter is the measure of the distance around a figure. Okay, circumference is the measure of the distance of the circle or around the circle. So, circumference. Okay, so given a radius, how can we find, like if I was to take this circle, if I was to unravel it, straighten it out, and measure that distance. How do you get that distance? That distance, circumference, is equal to 2 times pi times the radius. Okay, 2 pi times the radius. Another way people think about it is if you're given the diameter, d, you can use that instead. You just don't have to multiply by 2. So if you had the diameter, you could also use pi times d. Okay, so doing this is going to give you the measure of the distance all the way around the circle. Okay, What is pi? I think you guys have been introduced to that for sure by now. Pi is about 3.14, 141592. That's about as far as I go. Some people memorize the digits of pi. I'm not sure why. They do it though. But if you would like, we're just going to use 3.14 approximately for pi, or you can use the pi button in your calculator is fine as well when we're going to be multiplying our answers out by pi. All right, so that's how you find circumference. Now, another thing I wanted to talk about is arc length. Okay, arc length. And this is probably a new concept. I know you guys have been finding circumference of circles probably even since, I'd imagine at least 6th grade. They've been doing that. But let's talk about arc length because this should be new. Now, a lot of times students get confused between arc length and arc measure because they sound similar, but they're actually two different things. When I'm talking about arc length, okay, when I'm talking about arc length, I'm trying to figure out what is this distance. Okay, I'm not trying to find what is the measure of that central angle here. Okay, that's not what I'm trying to find. I'm trying to find if you were to straighten this thing out and measure it with a ruler, how long is this? Okay, that's what we're trying to find out. It does involve this central angle. Okay, it does involve that. But how would we do that? Well, it's basically related to circumference. Okay, if we're trying to find arc length, so say the length of arc AB. Okay, what is that? Well, it's related to the circumference. If I was to find the circumference of the circle, but only want this portion of it, how do I get that? Well, it all depends on what your central angle is. So the length of AB, if I'm given a radius, we still find the circumference. So take 2 pi r, but how much of it are we taking? We're taking whatever that central angle is divided by 360. So make sure, find the circumference. Okay, that's all 2 pi r is. Now this is how much of the circumference we're taking. Okay, imagine we had, and usually this clicks with students. Okay, imagine you had a straight angle. Okay, and we were trying to find this arc length here. Okay, how do we do that? Well, you can probably see that this is just half the circumference, right? Okay, this is half the circumference. So as an angle, that's 180 degrees, right? Okay, what's 180 over 360? Okay, well, that's 1/2, right? So that's what this here is doing for us. Okay, take this angle divided by 360, and that's going to tell you how much of the circumference you have. Just like if you were given half the circle, an angle of 180, that reduces to 1/2. 70 over 360, or no, not 70. Well, 70 was the other. I don't know why I'm saying 70. X over 360 is going to give you how much depending on whatever this angle is. We're going to do an example. I hope that's clear. I think maybe I kind of over-explained that. But let's do an example. So let's find some arc length. Let's look at this example. I'll take a picture. Oops, that's blurry. 1 second. Okay. Okay, you can't read it. It's kind of cut off, but it says, what is the length of each arc shown in red? So I'm trying to find that length there, okay? They tell us this arc is 240 degrees. Okay, that's the arc measure, and the radius is 15. So all we're doing is the length of, what is this, arc XPY. So that's arc XPY. That's equal to the circumference, which is 2 pi times 15. And how much of the circumference are we taking? 240 divided by 360. Okay, 240 divided by 360. So let's figure that out. Notice this, leave your answer in terms of pi in the directions. Basically, when it says leave your answer in terms of pi, you're not going to multiply by pi. You just kind of tack it into the end of your answer. I'll show you how it works. 2 times 15, that's going to give me a 30 pi times 240 over 360. And I suggest just going to the calculator for that. So 30 times 240 divided by 360. Okay, that gives me a 20. Now, typically when you're doing this, you would plug in 20 pi and you get your answer. But when it says leave in terms of pi, we can just leave this as 20 pi. And that's fine. 20 pi centimeters. Okay. But know how to do both. Like, they won't always say leave your answer in terms of pi. They might say to round it. So if they want you to leave your answer in terms of pi, 20 pi is perfect. If they want you to round the answer, we're going to take this 62.8. Okay. 62.8 centimeters. But again, they wanted you to give this answer. But practice doing both depending on what's asked of you. Okay. So that's how you find arc length. Okay, again, take the circumference and multiply it by your central angle divided by 360. We'll give you that answer. All right. Let me know if you guys have questions. Leave a comment, email, whatever you need to do. And that brings us to the end of today's lesson. Don't forget, we will have a progress check on Friday. Those are going to kind of be taking the place of our quizzes and tests for quarter 4, just because we're going to be online and things are going to be looking a little bit different. So yeah, miss you guys. Hope you guys are doing well. Peace.